The next question based on in a bilinear transformation. The next topic is bilinear transformation. Problem based on in a bilinear transformation. So you use the formula is W minus of W1, W2 minus of W3 divided by W minus W3, W2 minus of a W1. That is equal to Z minus of Z1, Z2 minus Z3 divided by Z minus of Z3, Z2 minus of Z1. So that bilinear is W is equal to AZ plus B divided by CZ plus D. A, B, C, D are complex constants. You find in a W value. The provided that condition AD minus of BC is not equal to 0. Why the name it call it as in a bilinear transformation means you rewrite that equation only in the form of linear form. There are two variable, one is W and A is Z. You cross multiply this side, you collect that one side equation, right side is 0 means that equation only form in the form of linear. There are two, one is W, another one is Z. So that's why that name is called it as bilinear transformation. So in this section you find the W value, this is in nothing but F in terms of a Z. So you collect in the left side is W, in your right side is Z term. So apply the formula is W minus W1, W2 minus W3 divided by W minus W3, W2 minus W1 is equal to Z minus Z1, Z2 minus Z3 divided by Z minus of Z1, Z3, Z2 minus Z1. Now problem based on bilinear transformation. First problem is find the bilinear transformation. Find the bilinear transformation which maps the points minus 2, 0, 2 into the points W is equal to 0, I minus I respectively. So Z1 equal to, Z1 is equal to minus 2, Z2 is equal to 0, Z3 is equal to of a 2. Same thing, this is now W1 is equal to 0, W2 is equal to of a I, W3 is equal to of a minus of I. I substitute a formula here. So W minus of W1 now. W minus W1. So W minus of 0, W2 minus W3. I minus I now. I plus I divided by W minus W3. W plus I. W2 minus W1. I minus of 0 is equal to next one Z minus of Z1. Z plus 2, Z2 minus Z3. Z2 is 0 minus 2. So 0 minus 2 divided by Z minus Z3. Z minus of 2, Z2 minus Z1. 0 plus 2. So W 2I divided by W plus I into I is equal to Z plus 2 divided by Z minus of 2 minus 2 divided by 2. So cancel here no, I also cancel 2W divided by W plus I is equal to minus. So minus of Z plus 2 divided by Z minus of 2. So usually you use in cross multiplication. So 2W Z minus of 2 is equal to minus of z plus 2 w plus I. 2w is z minus of 4w is equal to z into w. So, minus of z into w, z into I, minus of zi plus 2w, but minus is there, no, minus 2w plus 2I, here minus of 2I. So, bilinear transformation you find the w, no, in one side is w, remaining is z and the constant. Here w, this one is also w. So, 2w is z minus of 4w plus zw plus 2w is equal to 2 term minus I into z plus of 2. So, you combine now ZW. So, that is 3W is Z minus 4W plus. So, plus 2W is equal to of minus of I into Z plus 2. So, this is the W is equal to 3Z minus of 2 is equal to minus of I into Z plus 2. So, W is equal to minus I Z plus 2 divided by 3Z minus of 2 or Z plus 2 into I divided by Z minus of 2 minus of 3Z. So, here in a simple expression, so I cross multiply both the side. Sometimes the question W plus I or W minus of I, here W plus of 2 or W plus of 2I, something this will happen means you use the divided and a compounded rule. So, divided and compounded rule means A divided by B is equal to C divided by D. So, rule is A plus B divided by A minus B is equal to C plus D divided by C minus of D. Simple expression means you use the cross multiplication, or in the form means you use in a divided and a compounded rule. A plus B divided by A minus B is equal to C plus D divided by C minus D. So, here another important note of that type of question. Here consider 3 points in W plane, 3 points in a Z plane. No, in all the points not equal to infinity. Some values are there. Some question either Z1 equal to infinity or Z2 equal to infinity or Z3, at least one point is infinity. Same thing W plane also, at least one point W1 equal to infinity or W2 is equal to infinity or W3 is equal to infinity. Either one point is infinity. So, that time you apply the formula directly using that formula means in a infinity form. So, that time you neglect that particular point in a formula. Suppose we say Z1 equal to infinity. So, I consider in a right side of a formula for a bilinear transformation. Suppose say I consider Z1 is equal to of a infinity. So, Z1 equal to infinity means you rewrite that equation. So, taking out in Z1, Z divided by of a Z1 minus of 1, Z2 minus of Z3 divided by Z minus of Z3, Z1 no into Z2 minus of by Z1 minus of 1. Now, that Z is cancelled. There is no changes in a left side W formula. Only I change it in the formula is in a right side. You cancel that Z1, Z0. Now you apply infinity. So, Z by infinity is 0. So, here in a Z2 divided by infinity is 0. So, formula is minus 1 into Z2 minus of Z3 divided by Z minus of Z3 minus of 1. Only Z2 minus Z3 divided by Z minus of Z3. So, here I consider Z1 equal to infinity. Suppose Z2 equal to infinity means that time you taking out the formula is Z2 in a Z2. Not only in a Z plane. in a W plane also, in either any one of the point is infinite means you rewrite the equation. So now one problem based on that model. So now problem based on infinity. So the second question is find the bilinear transformation which maps Z1 equal to 0, Z2 equal to 1, Z3 is equal to infinity into W1 is equal to I, W2 is equal to minus 1, W3 is equal to minus I respectively. See here in your question Z3 is infinity. So in this formula you taking out in a Z3. So once again first I write it in a formula W minus of W1, W2 minus of W3 divided by W minus W3, W2 minus W1. So there is no changes in a left side formula. Only I rewrite the formula in a right side. So usual formula is Z minus of Z1, Z2 minus of Z3 divided by Z minus of Z3, Z2 minus of Z1. In your point is Z3 is infinity. So Z3 is infinity means you taking out that Z3, Z minus of Z1, Z3 into Z2 divided by Z3 minus of 1 divided by this Z3 no Z3 Z divided by Z3 minus of 1 Z2 minus of Z1. Now Z3 is cancelled no. So now infinity. So infinity means only Z minus of Z1 here my minus 1 divided by Z divided by infinity minus 1 Z2 minus of Z1. Based on your point you change the value. See Z1 infinity means Z2 minus Z3 divided by Z minus Z3. Z3 is infinity means in your formula is that minus into minus plus no only Z minus Z1 divided by Z2 minus Z1. So the W minus W1, W minus I, W2 minus 1 plus I divided by W minus W3. So W plus I, W2 minus W1. So minus 1 minus I, minus 1 minus I is equal to Z minus Z1 no that is cancel now minus 1 minus 1. Z minus Z1, Z1 is 0. So Z minus of 0 divided by Z2 minus Z1, 1 minus of 0. So right side is simple function only for Z. The right side is, left side is W minus I minus 1 plus I divided by, I taking out minus of W plus I into 1 plus of I. So here first you simplify, you cross multiply that side, you find the W is equal to some Z value. Or other easiest method is here 1 minus I divided by 1 plus I. Now denominator 1 plus I. I remove the 1 plus I use the conjugate. So one rationalized in a numerator and a denominator. 1 minus 1 plus I divided by 1 plus of I. So 1 plus I means I multiply 1 minus of I divided by 1 minus of I. I simplify in a that part only. So here A plus B, A minus B no, A square minus B square. So 1 squared minus of I squared. Numerator is you multiply each and every term. So minus 1 plus I minus of I squared. So answer is minus 1 plus 2I, I squared is minus 1, already minus is there, plus 1 divided by 1, I squared is minus 1 plus 1. So answer is 2I divided by of here 2. So 2 is cancelled, only the I know. So that purpose only I simplify this term. So W minus of I divided by minus of W plus I. This term is 2I only for I is equal to of Z. So Wi minus of I squared is equal to minus of z into w plus I, no, minus of zw minus I, here z is then minus of iz. So wi plus zw, I squared is minus 1, here plus 1, but that sign means minus of 1, minus of iz. So z is w is equal to z plus I, so minus of 1 plus iz. So w is equal to minus of, or you multiply minus inside, minus 1 minus of I, 1 plus of iz divided by z plus I. The next question based on w plane is infinity. So in third question, z is equal to 0 minus 1 I, w is equal to I 0 infinity. But here consider w3 is infinity, but some question w2 infinity or a w1 infinity. So previous question z plane is z3 point is infinity, but in third question w plane w3 point is infinity. Sometimes the question is, so in this question I consider in a w1 is infinity, so infinity 0 and a I. Formula, no, formula is in, now there is no changes in a right side formula. Z minus of z1, z2 minus of z1 divided by z minus of z3 divided by, yes, z2 minus z3 divided by z2 minus of z1. W minus of w1, w2 minus of w3 divided by w minus w3, w2 minus of w1. In your point is w1 is infinity, no? So w1, w minus w1 minus of 1, w2 minus w3 divided by w minus w3, w1, w2 divided by w1 minus of 1. So I cancel w1. Infinity, no, minus 1, w2 minus of w3 divided by w minus w3 infinity minus 1. So this 2 is cancelled. Final answer is w2 minus w3 divided by w minus w3. But right side in all the points is there. Z1 is 0, Z2 is minus 1, Z3 is equal to I. So that is equal to Z minus 0, Z2 minus 1, minus I divided by Z minus of I, Z2 is minus 1, minus 0. So that is equal to Z, minus is there. So minus of 1 plus I divided by minus Z minus of 5. So that minus is cancelled. So Z into 1 plus I divided by Z minus of I. So what is the W2? W2 is 0. 0 minus W3 is I divided by W minus of I. You know, this is for Z plus Zi divided by Z minus of I. Minus I, numerator is minus I, here I cross multiply that side, Z minus of I is equal to Z plus Zi into W minus of I. This is one of the method you use in a divided and a compounded rule. So minus of I is Z, minus into minus plus, I squared is minus 1, so minus 1 is equal to this term into W, no? So Z plus Zi into W. No need to split up. Y means I collected W equal to remaining part, no? So that's why W is the whole term. Minus of I into Z plus of Zi. So this one, no? So this is equal to minus of I Z minus 1. This is plus I Z minus Zi. So I into Zi, I squared minus of Z, but here minus is there, plus, but this side means only a plus is Z. is equal to Z plus Zi into W. Sorry, answer for in a IZ. Remaining is Z minus 1 is equal to Z plus Zi into W. So final answer W is equal to Z minus 1 divided by Z plus Zi. This is the final answer.